and welcome to another episode of Math Made Easy by Mrs. Roberts. This video is going to be the fourth episode in a series called Trig Integrals. So in this video, we are going to try a very tricky problem. We're going to find the integral of cosine to the fourth power of x dx. Now, here's the thing. We don't have cosine and sine, and we don't have an odd and an even power. So we have to think about this problem a little bit differently. What in the world am I going to do with cosine to the fourth power? Because if I try to do a u substitution with u to the fourth power, I don't have du. And so that u substitution is not going to work. Instead, I'm going to have to really think about my trig identities and see, is there something I can substitute in where maybe I can get rid of that power? So let's see what we can do. So what we want to do is we want to look at our possible trig properties, and is there a way we can rewrite our cosine to the fourth power in a way where I'm going to have a cosine that doesn't have a power? Or a sine, it could be sine or cosine, but right now if I were to try u substitution, I would say that I'm going to end up with u to the fourth du, where u is cosine of x. But that's not going to work because du would then have to be negative sine of x. And I don't have a negative sine of x in here. So really, the only way to be able to take the integral of this, at least the way that we know so far, is to have just a cosine of u. Because the integral of cosine of u would just be sine of u. Plus c, of course. And so we want to figure out, is there a way where I can just get a cosine or a sine without an exponent? So let's look at our different properties. Well, here's one set of properties. And I have a cosine to the fourth, and this allows me to change a cosine squared. But I could rewrite this as cosine squared of x squared, dx, which means I could use this rule. And when I use this rule, maybe I can get it down to just having a cosine of u, where my u is 2x. So let's try this out. Let's replace this cosine squared of x. Let's replace it with this. And let's just work it out and see what happens. Now, here's the thing about calculus. Sometimes you have to try different things. Sometimes the first thing you try doesn't work. That's okay. Let's just keep manipulating the math problems until it does work. So what I did was I replaced cosine squared of x with 1/2 plus 1/2 cosine of 2x, because that is what this property says is equivalent. And so I haven't actually changed this equation at all. These are still equivalent forms. And if you're worried about them being equivalent, you can always go into Desmos and just check it out. So in Desmos, sorry, I'm trying to pull it up over here. In Desmos, we can type in, well, I had cosine to the fourth of x. Desmos doesn't like it when you put the 4 there. So I had cosine to the fourth. Is that truly the same thing as? And what you'll see is it really is the same thing. These are on top of each other. And so they are equivalent. And so we have not altered this equation to make it not true. Okay? Well, right now, if I were to try to do u substitution, I would probably label this whole inside my u. Like I said, calculus, sometimes the first thing that you try doesn't work. So we would have 1/2 plus 1/2 cosine of 2x, which would make my du, well, this is 0. And when I integrate this, I would multiply a 2 out, and I would end up with sine of 2x. I don't have a du. Therefore, I can't do u substitution that way. I don't have a du, so this isn't going to work. And like I said, sometimes things don't work the first time. Don't give up. Keep trying. Try something different. So what we should try is we should try expanding this. So let's go ahead and expand it. So we're going to have 1/2 plus 1/2 cosine. You know what? Let's rewrite this fraction. Let's rewrite this fraction as 1 plus cosine of 2x over 2 squared. They have the same denominator. Why not just write them together that way? And the reason why we should just write it that way is because then we have this, right? So 2 squared is 4, so that means that this is really times 1/4, so we can bring that 1/4 out front. And then we only have to worry about expanding this inside without having any ugly fractions. So now that we expand that, we can get 1/4. Well, 1 times 1, we're going to have 2 cosine 2x plus cosine squared of 2x dx. And if you got lost in that expansion, go ahead and pause the video and actually FOIL this out. 1 times 1, 1 times cosine 2x times 1, cosine 2x times cosine 2x. You will get this. So now let's break this up into 3 separate integrals. I still haven't done anything that's making this equation not equivalent to the first thing. So this is all allowed. Haven't broken any math laws. So now what I've done is I have expanded this into 3 different integrals. 1, 2 cosine of 2x and cosine squared of 2x. I can integrate this piece and I can integrate this piece. This piece, I'm going to have to use a trig identity again. Because if I were to try to identify a u, I don't have a du yet. So we'll have to do a trig thing there, but let's integrate what we know. This, we can integrate it and we get 1/4 x. We can integrate this. Let's go ahead and do a little side note so that we don't doof it up. So side note, 1/4 2 cosine of 2x. Well, we're going to make this our u. So in the end, we are gonna want to integrate cosine of u du, but we have to make sure that we have our u and our du. So our u is 2x, which would make our du 2. So I do have that. I have my du right here, which means I can simply just integrate this. So 1/4, the integral of cosine of u is sine of u. And then remember, we always do the plus c, but we're going to do the plus c at the end of this big thing. So this integral becomes plus 1/4 sine of 2x. Now the last piece is we need to integrate this, but we don't know how yet because of that squared. So let's replace that squared again with this business. So when we replace that squared with this business, I'm just going to take this piece. This is going to be plus 1/4. That cosine squared we know is the same thing as 1 plus cosine of 2x, 2x over 2. I can move that 2 out. I can move that 2 out. And I get 1/8. And then I can break this up. 1 plus cosine of 4x. Now I can integrate. So this is going to integrate into 1/8 x. And in the end, when that's 1/8 x, we are going to want to add our 1/8 x and our 1/4 x together. So when we add our 1/8 and our 1/4 x together, we're going to get 3/8 x. So I integrated this and added it to this. 1/4 plus 1/8 equals 3/8 x. And now we want to integrate this. So when we integrate that, we are going to say that u is 4x, meaning du is 4. I don't have a 4 here. So in order to add a 4 here, I have to add a 1/4 out here. So I'm going to get 4 times 8 is 32. And then I can integrate cosine of u du, which is going to be sine of u. So sine and our u, and then plus c. So that is our final answer. And what we found was there were a couple of times when we tried something and it didn't work. And that's okay. We figured out it didn't work, and so we did something else. That is perfectly acceptable. That happens sometimes. Just don't give up. Just keep trying. So I'm going to give you one to try. So I would like you guys to try this one out. And when you get an answer, you can drop it in the comments below so that other people can check their work based off of yours. So I hope this video was helpful, and I'll see you in the next episode.